So now our next question is question number 5. Differentiate x square minus 1 over x square with respect to x4. The only change in this question is we have not naming convention here. A function is to be differentiate with respect to another function. So this is a thing like if we have x square minus 1 over x square is y and x4 is another function which is named by say u. So if we apply this sentence into this naming convention, so x square minus 1 over x square is actually our y, and with respect to this x4 is named as u. So the line will now become differentiate y with respect to u. So if we want differentiate y with respect to u, so we have to just calculate a thing like dy by du. So now we start our procedure by naming this one x square minus 1 over x square and x4, and then we will form our required result solution. So let y is equal to x square minus 1 over x square. So here y is the function of x. So by applying differentiation here, differentiate with respect to x as y is the function of x. So now dy by dx is equal to derivative of x square will be 2x and derivative of 1 over x square, which is this one. Actually we are doing here y is equal to x square minus this 1 over x square can be written as x raised to the power minus 2. So when we apply differentiation on this one, so that will become dy by dx, which is left hand side, and on right hand side derivative will apply both of these terms separately. So when we apply derivative on x square by using our power theorem, that will become 2x2 minus 1, which is 1, and this minus will be as it is, and derivative of x raised to the power minus 2 again by using our power theorem, that will become minus 2 x raised to the power minus 2 minus 1, which will become minus 3. So we have 2x, this minus and minus will become plus, and 2 this x raised to the power minus 3 by shifting it to the denominator, that will contain a power in positive sign. So we have 2x plus 2 over x raised to the power 3. By taking LCM x cube, we will have 2x raised to the power 4 plus 2, which is dy by dx. By taking common 2, that will become x4 plus 1 divided by x cube. Next, let u is equal to x4. Actually giving a name to this function x4. Now differentiate this u with respect to x, that will become du by dx is equal to 4x raised to the power 4 minus 1 will become cube. So 4x cube our du by dx. Now by using chain rule, dy by du, as we discussed earlier, that we have to form dy by du, as we have to calculate differentiate y with respect to u. So this is actually dy by du is equal to dy by dx into dx by du. So putting the values on dy by dx, which is 2 into x4 plus 1 divided by x cube into dx by du, we have 4x cube of du by dx. In the previous slide we have du by dx is equal to 4x cube, but in the chain rule we have to form dx by du. So by taking reciprocal of this function will become 1 over 4x cube. Now by dividing 4 to 2, that will become 2, and x3 into x cube will become x raised to the power 6, and in numerator we have x4 plus 1. By multiplying 1 will become x4 plus 1, which is our required dy by du, and this is actually a differentiation of x4 x square plus 1 over x square with respect to x4. Now our next question is differentiate 1 plus x square raised to the power n with respect to x square. Again, using the same process by giving a name to both of these functions. Let y is equal to this one and u is equal to this one, and that will become actually differentiate y. If we giving a name 1 plus x square raised to the power n to y, and differentiate y with respect to this one is supposed u, so that will become now differentiate y with respect to u. Again we have to calculate dy by du by applying derivative on both of these functions separately, and then using chain rule we will form our required result dy by du. Same process, y is equal to, let 1 plus x square raised to the power n, and differentiate with respect to x by using our power theorem here, n into 1 plus x square raised to the power n minus 1 into derivative of the inner function, which is 1 plus x square. When we apply a derivative on this inner function, derivative of 1 will become 0, and derivative of x square will become 2x by using power theorem. So we have 2nx into 1 plus x square raised to the power n minus 1, which is dy by dx. Now first we give name to the x square. This is actually x square, this one is actually x square, not x4. So u is equal to x square, differentiate with respect to x, that is du by dx is equal to d by dx of x square, which will become 2x. So now we have du by dx and dy by dx. By using chain rule we will form dy by du. So by using chain rule, dy by du, which we have to form by using chain rule, dy by du is equal to dy by dx into dx by du. Our required result is actually dy by du. So by using chain rule of both of these two derivatives, which are du by dx and here dy by dx. So using these two derivatives in chain rule, we will calculate dy by du. Putting the values dy by dx, which is 2nx 1 plus x square raised to the power n minus 1, and dx by du. Here we have du by dx 2x, but in the requirement of chain rule we have dx by du. So taking reciprocal of this one, du by dx, which will become 1 over 2x. This 2 and x will be cancelled out. We have only dy by du is equal to n into 1 plus x square raised to the power n minus 1.